incrementando las capacidades técnicas para la conservación de la biodiversidad. En esta oportunidad, la charla va a estar a cargo de Duanyang Liu y la traducción la realizará Sebastián Martinuzzi. Bueno, nuevamente queremos agradecerle al Silvis Lab de la Universidad de Wisconsin-Madison por organizar esta serie de seminarios. Como opción para escuchar la charla, pueden ir a la opción que figura al final de la pantalla, que es el más, y ahí pueden tener interpretación y ahí pueden seleccionar si la quieren escuchar a la charla en inglés o en castellano. Y con esto le damos la bienvenida y el agradecimiento nuevamente a Liu y a Martinuzzi.
Okay, good morning, everyone. Thanks for the kind introduction from Natty. And it's my great honor to be here and have this opportunity to share my research with you all. And today I'm going to talk about the dynamic habitat indices from MODIS and VIIRS data and their relationship with biodiversity. Here are 5 parts to my talk. First of all, I'll explain the background about my research, and then I will introduce what DHI are and how to calculate them, and then some corresponding results. And after that, I will show you how to apply those DHI in our research and provide some case studies. And in the end, I will provide some conclusions and recommendations. As we know, the biodiversity is the foundation of a healthy ecosystem, and each species, no matter how small they are, plays an important role in maintaining the balance of nature. And the World Wildlife Fund releases the new Living Planet report in 2024, which highlights about 73% decline about the global wildlife population over the last 15 years. And for example, in this figure, you can see that the coral species are experiencing rapid decline in survival. And also in this figure, the blue line, you can see the species in Asia are also facing large risk of extinction. Therefore, it is important to understand the distribution of biodiversity. Until now, many ecological theories have been proposed to explain the distribution of biodiversity, such as available energy, environmental stress, and environmental stability. First of all, for the available energy theory, they said the high speeds usually happened in the high available energy area. This is because the higher input energy from the solar radiation increases the net primary productivity, which is NPP of the place, and increase the accumulation of biomass and provide more food and health resource for the wildlife. For example, in this figure shows almost a positive linear relationship between the actual evapotranspiration and the birth reachings in the forests of North America. And the x-axis is the actual evaporation, which is reflect the amount of water transport from the ground surface to the atmosphere. And this value are mainly controlled by the energy and the moisture, but it's usually regarded as the best climate variable to characterizing the net primary productivity. And the second one is environmental stress series, and which states that the environmental stress is a place with high environmental stress would not suitable for many species. And the environmental stress refers to the limited food resource or extremely high or low temperature or humidity. For example, in this figure, that over the north hemisphere, that the temperature will gradually drop from the equator to North Pole. And the species ratings also rapidly decrease because as the latitude increase and the environmental stress faced by the wild animals are also rapidly growing. And finally, in the environmental stability, they said if a place has frequent disturbance, such as great up and down temperature or rainfall, and some other environmental variables, and this place may not suitable for most species. For example, in this figure, that people evaluated the relationship between the rainfall seasonality and bird abundance over North Australia. And they found that there is a strong negative relationship between the variation of rainfall and bird abundance. Meanwhile, the remote sensing also provides large-scale, long-resolution and high-resolution and long-term observations. And the remote sensing works by actually detecting the electromagnetic radiation, usually the sunlight, which is reflected by or emitted from the land surface. The different land surface, like the vegetation, soil, water, they reflect the energy in unique ways. And those sensors can capture this reflectance as digital information and then process this information into image raster or data layers, and allowing the scientists to monitor environmental change or assist the vegetation health. And until now, there are lots of remote sensing satellites in space. And in my study, I depend on the two MODIS sensor, Tyra Aqua, and also the VIIRS satellite. And you could find the two sensors over here. And also here is a summary of the characteristics of the data from MODIS and VIIRS. And those satellite data provide a large number of Earth observations, and the product divided from those satellites are useful for predicting and understanding biodiversity patterns across different spatial and temporal scales. Combine the spectral and biophysical characters of vegetation. The sensor on those satellites can effectively characterize the different aspects of vegetation, such as the vegetation greenness or the efficiency of sunlight used or how much carbon it captured. And the different vegetation indices provide different aspects of those information. So for example, from the remote sensing, we can calculate the normalized difference vegetation indices, which is known as NDVI. And this indices value is based on the near reference and red reflectance spectral bands. You could find the equation here, and the NDVI indicates the vegetation greenness and health. And here are 4 more vegetation indices, and each of them capture the slightly different characteristics of vegetation. And the red map is an example about the vegetation indices application. And this map shows the trend of global vegetation greenness and the corresponding significance level from 2001 to 2021 based on the MODIS NDVI product. And the chart below here shows the variation in change over different parts of the Earth. And in this map, we can see the biggest greening increase was in the North American, Central Africa, and Europe, and Southeast Asia. And this information is super helpful for the global monitoring of vegetation dynamic. Given the rigorous ecological series and the powerful remote sensing tool, and we are thinking about how to combine them together and provide a powerful framework for understanding, monitoring, and conserving biodiversity. Because the ecological theory could help us to define what we should measure using remote sensing technology and how to interpret and apply those measurements in biodiversity. Based on the background knowledge about, we developed the 3 standardized metrics for using in biodiversity models. And they're called the Dynamic Habitat Indices, which is DHI. And they are designed to characterize the land surface vegetation productivity over the multiple waves. And here I'm going to explain how to calculate the DHI. And the left finger is time series vegetation indices for over 1 year. And from this data, based on this data, we can calculate the 3 DHI variables corresponding to the 3 ecology series. And for the available energy, we have the cumulative DHI by summing all the vegetation indices over 1 year. And this will reflect the landscape productivity capability. And for the environmental stress, we have the minimum DHI by selecting the lowest vegetation indices within 1 year. And this will indicate the environmental stress level. And as for the environmental stability, and we have the variation DHI, and which reflects the fluctuation of vegetation productivity within 1 year. And in my work, I used the vegetation products from MODIS and VIIRS. And I used 5 different vegetation products, and each for a 10 years time period from 2013 to 2022. And here the NDVI, UAI, RAI, FPAR, and those 4 products are from both MODIS and VIIRS. And we also incorporate the GPP from only MODIS. And notably, I used the 5 vegetation products here to calculate the DHI, because a single product such as only the NDVI, they can only capture 1 dimension of vegetation dynamic, like the vegetation greenness, but may fail to represent the structural attributes like biomass, photosynthesis activity, and so on. And furthermore, the performance of 1 single vegetation product may different across different biomass. For example, the 1 product may perform well in grassland, but perform poorly in the borough forest, which may introduce the base or misinterpretation when applied across the different ecoregion. And here is a flowchart about the DHI calculation process. And before calculating the DHI, we used the quality control metrics to remove the low quality observations. And for example, in the right finger, and this is the quality control flex over the 10 years. And this is in the original input FPAR within datasite. And here the right in this place, they label that those observations or this time has a very low quality or maybe all covered by cloud. And then we will remove those values and got the high quality results over here. And the next step is to collect the median observation over the 10 years after the refinement process. And as shown in this finger, the blue points are the observation after the refinement, and the red point actually was the selected medium observations. And then based on this medium observation, we have that will represent the composite 10 years vegetation dynamic. And we will calculate the 3 DHI based on the equation as we mentioned before. And here are some results about the global DHIs. And the top finger is a red, blue, green, and blue map that combines the 3 DHIs based on the MODIS Aqua UAI. And the bottom are the 3 individual DHI variables. And you can see that from this map that the high cumulative and the minimum are mainly concentrated in the equator areas, such as northern Brazil and Central Africa and Southeast Asia. And those places are mainly covered by the tropical or subtropical forest, and which offer the abundant food resource and minimize environmental stress for wildlife. However, for the place with the low cumulative and minimum air are mainly found in the desert or the very high latitude air, such as North Africa, Greenland, or northern Russia air. And those places are mainly covered by the shrublands or low vegetations, which provide limited food resource and a huge pressure for the wildlife. However, for the variation DHI, the value are gradually increased with the latitude in the North Hemisphere, and particularly in the middle and the high latitude, because those places are mainly covered by the temperate vegetation, which had a clear seasonal variation. And here are the DHI from the other 4 vegetation products based on MODIS ACRA satellite. And generally, those DHI maps show similar distribution patterns. And notable in the DHI based on FPAR, RAI, and GPP product, the non-vegetation or low vegetation air, such as Greenland or the North Africa or Qinghai, Xinjiang platitude, they are masked as noted. In the prior slides, you see some DHIs based on the different vegetation products, and the DHI, those products slightly emphasize slightly different photosynthesis characters of vegetation. And here is a general guideline of the application when using those DHI products. And for the NUI and UI based DHI, they are effective in monitoring vegetation greenness, and because they are simple, consistent, and global available, and robust to analyze across space and time. Especially for the UAI-based DHI, has the advantage to reduce the atmosphere and the soil background and noise. And the FPAR actually estimates the fraction of sunlight used for photosynthesis, closely linked to the vegetation productivity. And so the FPAR-based DHI would more efficient to estimate the energy carbon cycling in the ecosystem model. For the RAI, it estimates the amount of leaf surface air, and the corresponding DHI are more useful in ecosystem function modeling and vegetation growth analysis. The GBP is a direct measurement of carbon uptake from the photosynthesis and integrate many physiological processes. And so the DHI based on GBP are more suitable for carbon cycle study, climate change research, or ecosystem productivity assessment. And here are the DHI from the MODIS Tyra and VIIRS from VIIRS products, and created by using different vegetation products. And as we know, the MODIS sensors are both more than 20 years, and they will stop working soon. So it's important to for studies to change through the MODIS to the VIIRS this side. And over this result, we could see that the DHI from MODIS and VIIRS has similar distribution patterns, which means we could able to use VIIRS in the future. And you can find all the DHI products I mentioned in our lab web page. And please feel free to download and apply those DHIs in your research. And we plan to regularly update the DHI products, and we encourage their more used in research and policy applications. After you download the DHI from our website, you can clip a region of interest from it. And here is a simple example of our script clipping the DHI for Argentina. And now I would give some examples of how I have used the DHI in biodiversity study. And here I test the performance of the DHI in predicting the biodiversity patterns. And I collect the global species richness map of 4 taxons, which is amphibian, birds, mammal, and reptiles. And you could find those species richness map from the IUCN website over here. And after that, I collect the species richness and the corresponding DHI values over about 7,000 random points at a global scale. And based on those collected samples, I calculate the Pearson correlation between the species richness and the 12 variant DHIs from 3 sensor and 4 vegetation products. And in all those, from this result, we could find that all the DHIs has a significant correlation with the species richness, and the 3-star in each cell indicates the p-value at less than 0.001 significant level. And this result shows that how robust the DHI are with the species richness over global scale. And notably from the color of those results and the cumulative in green box and the minimum in glow box has a significant positive relationship with the species richness. And however, for the variation DHI, which in the red box has a significant negative relationship with the biodiversity. These results actually match well with the ecology series we discussed before. For example, an area with the variation in greenness is high during the annual cycle would support fewer species than the other place. And after that, I use the DHI based on each vegetation product as input variables. And the species richness were serving as the response variables to build the random forest regression models. Given the 7,000 random 7,000 samples points, and 18% are randomly selected for a training model, and the remaining 20% were used to test the accuracy. And I calculated the RMSE based on the prediction and the real observation for from the 20% samples. And moreover, I also presented the relative importance of each DHI variables and evaluated their contribution in prediction species richness. And in this figure, there are the results for the amphibian, birds, mammal, and reptiles. And the number in the x-axis represents the corresponding DHIs, and each column represents a different DHI. For example, the number 1 is the Tyra EVI DHI, and the number 2 is Tyra NDVI DHI, and so on. And the lessons of the different bar indicating the corresponding contribution of each DHI variables. And the black dots and the light represent indicates the prediction accuracy and are relative to the right y-axis. In this result, I found that the GPP-based DHI for all the species model has the lowest error, which means the GPP has the best performance in predicting the species richness over global scale. Because the VIIRS does not provide all the input for GPP estimation, so we don't have the GPP-based DHI for VIIRS. But out of the GPP-based DHI, the VIIRS with the same vegetation products, the VIIRS also show a better accuracy than the MODIS-based DHI. And over all those models, the amphibian species prediction model show the best prediction accuracy and based on the lowest RMSE value. And regarding the relative importance, we found that the cumulative DHI made the most contribution in predicting amphibian, birds, and mammals. But the variation DHI, we found they are more important than the other in predicting the reptile species richness. And here are two more examples about the DHI application from the other people. And first of all, in this research, John used the cumulative DHI to analyze the migration density for large herbivores like the camel and antelope. And in the left map, in the left finger, you can find that the migration density has a clear negative relationship with the cumulative DHI. And this could be explained in the finger on the right side. And imagine if one place has low productivity and they would provide a limited food resource, and the wild animals may stay for a short time, and they will have long migration to some place where has high productivity and provide more food resource. And they will stay those places for a long time and has a short migration. And here is the second example of how the DHI were used to identify the behavior of Anise conda in South America. And this work was done by Paula, who is from Argentina and got her PhD at the University of Wisconsin. And those authors found that the probability of fogging and roasting is lower at a space where the cumulative and the variation DHI are high. Because but the probability of flying over a place is not relative to the DHI. And this result are helpful for monitoring the conda population. And here are several conclusions about this research. And in this research, we generate the global 500-meter DHI based on MODIS and VIIRS product. And those DHI can effectively capture the distribution of global vegetation productivity. And over the species richness prediction, and we found that the DHI demonstrates the acceptable RMSE accuracy in predicting global species richness. And where the MODIS GPP DHI has the best accuracy. And moreover, the DHI are widely applied over the relative fields, and which indicate their great potential in biodiversity monitoring and conservation. And in the end, I would like to provide some comments for people when using the DHI. And first of all, when selecting the among various DHI products, the user must consider both the performance of DHI and their specific research needs. And for the global biodiversity monitoring, the MODIS GPP DHI are the optimal choice across all species. Out of the GPP, the VIIRS also show higher prediction accuracy compared to the MODIS-based DHI. And given the MODIS will overpass their design life, and we recommend to an increase receding on VIIRS DHI for biodiversity monitoring. At a regional scale, and the user should consider the availability and reliability of the DHI. And for example, in places with the low vegetation cover, such as the Sahara Desert or Xinjiang Plateau or the Greenland, the EVI and NDVI-based DHI are the only available options. But in the tropical forest area, the frequency cloud cover and the density forest would reduce the accuracy of NDVI-based DHI. And furthermore, when selecting the DHI variables, the people should also focus on the specific roles of each DHI variables in their study objective. For example, the variation DHI are more important in analyzing the distribution of reptile species. And here I would like to thank to NASA for providing funding to support our research. And moreover, I also appreciate the contribution from our team members, and they are Walker and Duda, Lina, Dave, Akash, and Connor. And these are all my presentation, and thanks for your attention. And I would like to take the questions part.
Duanyang,
can you hear me?
Yeah, I can hear
Okay,
you.
so I'm going to translate one question that appears in the chat.
Okay.
But people, feel free to raise your hands or and ask a la gente. Siéntanse libres de escribir en el chat o alzar la mano para preguntas. Hay una pregunta de Noelia González. I'm going to translate for you, Duanyang.
Okay. Thanks.
So good morning, Duanyang.
Yeah.
Thank you very much for your presentation. My question is, why do you think the models predict better for amphibians than the rest?
So model, sorry, Seva, can you?
Why your models have better fit for amphibians than
the
for
model,
the other, for birds, mammals, and reptiles?
Well, that's a good question.
Perhaps I could help with that question.
Yeah, thanks, Anna.
Sure. Because amphibians are often detected when they're calling or singing, and it's at that time that they are very close to water or in water. And I think productivity of vegetation is high around water.
Okay, Anna, give me 1 second so I can start translating. Voy a empezar a traducir un poco, Noelia y el resto. Lo que está diciendo Ana, que una potencial razón por la que los modelos son mejores para los anfibios es que generalmente están cerca de cuerpos de agua, humedales que pueden llegar a tener alta productividad. Y estos modelos capturan productividad bien. Ana, go ahead.
Okay, the other part of it is the bias in detection in data on amphibians. We primarily have it for temperate latitudes and not so much for tropical latitudes.
Okay,
So,
1 second. La otra razón también puede ser que hay un sesgo en la distribución en los datos que tienen de la distribución de anfibios. Generalmente está la distribución de anfibios la tienen para áreas templadas y no mucho para los trópicos. Go ahead, Ana.
So those are just two ideas that I have for why it's better, because it's not taking the models, the data isn't equally distributed globally, it's concentrated. I think it's an artifact of that data availability.
Noelia, bueno, dice que esas son las dos razones, que sí, sobre todo el hecho que los datos no están consistentes, distribuidos a nivel global, que están como sesgados para arriba. ¿Tiene sentido, Noelia, la respuesta?
Very, thank you. Yes.
Más preguntas, more questions, en inglés, in English, in Chinese, no. I cannot help there. A los que hacen preguntas, por favor, lo veo que están todos muteados. Siéntanse libres de preguntar. Acá hay... Acá. Okay, there is another question from Brenda Pizzano. Can you hear me, Duanyang? Yeah, right?
Yeah.
Perfect. So I'm going to go ahead with the translation. So thanks for the presentation. For mountainous regions of grasslands or with low vegetation, which DHIs derived from EVI or NDVI do you recommend the most? For example, for the study of the distribution of mammals. So basically this is, which DHI do you recommend for mammals in mountainous places with low vegetation cover, so grasslands or low vegetation?
I think for the DHI from MODIS from the NUI or UI, they have quite similar patterns and also performance in predicting species regions. And you can, I think, consider I don't know exactly the place, but you could consider the availabilities from the NUI and UI. They are all available. So I think there's no probably big difference for the low vegetation, such as
so if you need to recommend estoy ahí hablando, Brenda, igual. So if you need to recommend one that will be from EVI or NDVI in mountainous grasslands, which one would you be? Or is the same?
I think they are probably the same, no big difference.
Dice que, para resumir, Brenda, que no habría mucha diferencia entre el EVI o NDVI en esas zonas con poca vegetación.
Yeah, so UI has more advantage in the high density vegetation area, like the forest.
Dice
the
que
UI are better than NDVI. So for the grassland.
Let me translate. Lo que dice que la diferencia entre esos dos índices, entre los DHI derivados de esos dos índices, la diferencia está más que nada en zonas de vegetación más vigorosa, que parecería no ser tu caso, ya que está hablando de pastizales y áreas con poca vegetación. Brenda, ¿se entendió?
Yes, thank you. Thank you very much.
Por supuesto, aquellos que quieran preguntar en inglés y que responda él directamente en inglés, no hay problema. Ivana, a question from Ivana. Hi, the scales are, so the products you use are global scales. Have you tried to have them at regional scales?
So you mean the DHI calculation or the application?
Ivana, la pregunta que te hace Duan es los productos o las aplicaciones. Porque los productos también podés cortarlo por una región que vos quieras. ¿Podés explicar eso si te referís a los productos o las aplicaciones? Applications.
Honestly, in my research, I applied in globally and not in regional scale. But there are the two more examples I provide here. They are using the DHI applied in regional scales. So I think there's no problem if you want to apply those DHI in the regional scales.
Okay, perfect. One second. En la tesis de Duanyang, él está usando más que nada a nivel global. Pero por supuesto que se pueden usar en aplicaciones regionales. Y un ejemplo es el de Paula Perry, que es el que de acá a la izquierda. Ella es la chica que hizo la tesis en la Universidad de Wisconsin. Ella es de CONICET. Me parece que está en Bariloche ahora. Pero sí, se pueden usar en aplicaciones regionales. Thank you, Duanyang.
Thank you, Seba.
Y gracias, Ivana.
Seba. There was another question from Romina.
No la vi. Ay,
Okay.
acá, una más, perdón. Romina, Agua y Sol. Duanyang, I'm going to go ahead. Which DHI do you think is better for highly urbanized regions?
Highly urbanized. which DHI is more?
That's a tricky question.
Yeah, I because my data was my performance, the test that was global scale. I can't give the specific answer which one is better in the specific place. Maybe, but we can.
Ivana, Romina dice que como el estudio de él
Yeah.
es a nivel global, se le hace como difícil ver cuál sería mejor específicamente para esa región con mucha urbanización. Sobre todo para buscar adentro, o sea, en lugares donde tenés adentro de las urbanizaciones.
Sebastian, it might be helpful to know what the application would be in urban areas, like looking for habitat or estimating, urban, heat
Dice que
island
algo
effect, or
importante.
like what's the application?
Sí, Romina, ¿qué tipo de aplicación sería para buscar, por ejemplo, para identificar hábitats? Dice que es una pregunta importante para saber qué DHI a lo mejor podría funcionar mejor.
And I'll just say we can follow up. Oh,
I see. Yeah, to assess birds distributions.
Oh, the birds species.
so in my opinion, if you're interested in forest birds, then
Si están
a
interesada en los...
EVI-based cumulative DHI would be very useful. What do you think?
One
Gwen?
second.
Yeah.
Lo que dice, otherwise I will forget, Ana. So, lo que dice Ana, que el DHI cumulativo debería ser útil si te interesan las aves asociadas a los bosques.
Duanyang, do you agree?
Yeah, I agree that the community usually the best variable in the birds or amphibian and mammals. Yeah, you can't ignore that.
Sorry, could you repeat that part? Sorry, I didn't hear
Yeah.
you.
I agree with Anna that the cumulative is the most important variables for the birds.
Perfecto. Y Duanyang concuerda con Ana que el cumulativo de los DHI sería el mejor.
And EVI because it wouldn't, reach the threshold. It wouldn't saturate.
Y usando el EVI, no el NDVI, sino el EVI en caso que sea para que no se sature en caso que sea vegetación vigorosa. And can I add one from my perspective?
Yeah,
These
sure,
are also
go ahead,
500-meter pixel, so maybe it's not the pixels. The pixel size is not ideal to look into urban areas, right? Un punto más que me autorizan a hacer de mi parte, Romina. Estos productos tienen un tamaño de píxel de 500 por 500 metros, 500 metros por 500 metros. Dependiendo del tamaño de tu área de estudio, si a vos te interesa una ciudad y la parte de los suburbios de la ciudad, a lo mejor el píxel es demasiado grande para vos analizar bien patrones de vegetación en áreas urbanas. Acuérdate que son 500 por 500 metros, ahí a lo mejor hay que usar algo mucho más chico.
Y por ahí también recordar que los productos del Service Lab están disponibles para descargar gratuitamente.
Sí, en el link de la página nuestra están accediendo y están los links para bajar todo. ¿Más preguntas, consultas? ¿En inglés, en español? ¿Algo italiano? ¿Poco?